So we're going to start by looking at significant figures. They're also called significant digits, or by their short forms, which is sig figs, or sig digs for significant digits. Same sort of idea. Before we can dive into that though, we just need to review scientific notation. I'll do this quickly because you've seen scientific notation before, but just make sure we're all on the same page there. There's basically two different types of numbers you can put in scientific notation. It's a number bigger than 1 or a number smaller than 1, some sort of decimally number. If you have a big number like this, then what I'm looking at doing is writing this number as a power of 10, and I have to figure out how far I have to slide the decimal so that it's after just one digit. So I'm going to put my decimal right here. So there's a single digit and then my decimal place. How far would I have to slide the decimal to get there? Well, it starts out here, right? That's the decimal place initially. I have to slide it 1, 2, 3, 4 places to get it where I want it to be. That means there's 4 powers of 10 here, or 10 to the power of 4. So to rewrite that number in scientific notation, I write it as 2 point, so put the decimal right after the first digit, 2.2651, I just write out the rest of the number, and then times 10 to the power of however far I slid that decimal place, which was 4 spots. Cool. Here's a decimally number. How we do this is exactly the same. I'm going to put the decimal place right after the first non-zero digit, so that's the 2. I want the decimal there. How far do I have to slide it? It's actually also 4 places. 1, 2, 3, 4. But I had to divide by 10 4 times to get there, or in other words, 10 to the negative 4. So I'll write out my number, 2.033 times 10 to the negative 4 would be this number in scientific notation. So again, single digit before the decimal, write out the rest of the number. And the exponent here is just going to be how far you have to slide your decimal. It's negative if you have to go this way, like if it's a decimally number. It's positive if you have to go this way, like if it's a big number. Cool, that's scientific notation. All right, significant figures. So real life isn't perfectly precise. In real life, if you talk about a length, you might say something is 3 meters long, but we have to talk about how precise that 3 meters is. Is it 3 meters plus or minus maybe 20 centimeters, like 0.2 meters? Is it 3 meters maybe plus or minus 0.02 meters, like just 2 centimeters? Or maybe plus or minus just 2 millimeters or 5 millimeters, or I don't know. So in physics, when you get a little bit further, we're going to have this sort of idea here, this plus or minus bit. That tells you exactly how certain you are of that length. So in this case, I'm not certain up to 0.2 meters. That means the length could be as low as 2.8 meters up to 3.2 meters. It could be 0.2 meters below our estimate of 3 meters, 0.2 meters above. So that's what that uncertainty here tells me. The problem is that at our stage in the game in physics, we're just starting out, our numbers are not going to have that uncertainty value on them yet. We're just going to get things like this. The length is 3 meters long, 3.0 meters long. So then how do I know how certain I am about that 3 meters? Well, the thing is, the number itself is actually giving you a clue about how certain it is or how wrong it might be. That number could actually be maybe 3.2, could actually be 3.1, could be 2.9, and I've sort of rounded it off, I'm not sure. You can tell how certain you are of the number if you look at the number of significant figures. And that is what we're learning about in this video. So first, how do we even count how many significant figures a number has? First, all non-zero numbers count. So that's numbers like 1, 2, 3, 4. Any number except for 0, those all count. Those digits are significant. If you have any zeros before your number starts, they don't count. But if you have zeros after your number starts, like after you get these normal digits like 1, 2, 3, that kind of thing, those do count. All right, those 3 rules make more sense when we actually practice with them. So here's a number. How sure am I of this number? In other words, how many significant figures or significant digits does it have? Well, all non-zeros count, so that's the 3, the 2, the 4, the 5, and the 3 all count. Any zeros that are before the number starts wouldn't count. But this 0 is after we've gotten into our number, so that 0 counts. That means I have 1, 2, 3, 4, count the 0, 5, 6 sig figs there. So there are 6 sig figs in that number. Here's another number. The 1 counts, the 2 counts. These zeros are after our number has started, so they all count. 1, 2, 3. So there's 5 sig figs altogether. Here we've got a lot of zeros. They are before our number starts, right? The first non-zero number is just the 3. Any zeros after that would count, but all the zeros before do not. So there's only 1 sig fig there, and it is the 3. So there's 1 significant figure there. Here's a number with some zeros before don't count. The 0 after counts. The 4 itself, of course, counts. So there are 2 sig figs there. Now here's some numbers in scientific notation. Good news about scientific notation. For counting significant figures, this part does not matter at all. So you don't have to like rewrite it in non-scientific notation to figure out sig figs. You actually just have to look at this piece, like just the regular number piece. That tells you how many sig figs you have. Of course, this is important for like knowing what the number is, but this is all you need to look at for how many sig figs it has, how many significant figures there are there. Okay, so the 3 counts, the 4 counts. These are zeros after, so they count. There's 4 sig figs in this number. And our last number, 10 to the 4, this piece doesn't count. Just the 2.1 counts, the 2 counts, the 1 counts, there's 2 sig figs there. Alright, so that's how we count how many significant figures a number has. But in order to really tell the truth about how accurate a number is, what I need to do is propagate significant figures through a calculation. This is what you're going to be doing in our course all the way through. In every single problem you do, you're going to report your answer to the right number of significant figures. So this is basically an issue that comes up really quickly in physics. People often will ask me, how many decimal places should I report? The answer is report the right number of significant figures every time, every problem that you solve. There's really 2 main types of math you'll be doing. You'll probably be doing lots of multiplying and dividing in this course, and you'll do lots of adding and subtracting. And there's slightly different rules for how to propagate significant figures through when you're multiplying and dividing versus adding and subtracting. Most of the time you'll be multiplying and dividing, so this is the most important rule to know. Every once in a while you'll also be adding and subtracting, so it's good to know that one too. Alright, so how many significant figures should your answer have if you calculate it by doing a bunch of multiplying and dividing? It doesn't matter if you multiplied and divided 2 numbers or 7 numbers. What you're going to ask yourself is, what is the smallest number of significant figures in either of the variables or any of the like 10 variables that you're multiplying and dividing? So look at all your variables, which one has the smallest number of sig figs? Your answer needs to have that number of sig figs. So I'll show you with a few examples here. So here we've got some numbers being multiplied together. Let me just grab a calculator. Okay. So here I've got 204.552 being multiplied by 3.2256. And my calculator spits out this huge number, lots of decimals, right? But how many sig figs can my answer have? For that, I look back at the numbers that I'm multiplying or dividing, doesn't matter. This one has 1, 2, 3, 4, 5, 6 sig figs. This one has 1, 2, 3, 4, 5 sig figs. So that means my answer must have 5 sig figs. So I have to have the smallest number of significant figures in my answer. So I'm allowed to write this down to 5 significant figures. So that would be 659.80. This often feels weird for people, writing that 0, right? It feels like, oh, I could just end at the 8. That 0 is important because it tells us that I'm sure right up to the 0. It's not like 0.81 and I just rounded it. It is indeed 0.80, like I'm sure of the 0. I'm not sure of what comes after it, but I'm sure up to the 0. And that's why we use significant figures to tell us how certain we are of our number. Let's try the next one. So here I've got 2 sig figs. Here I have 1, 2, 3, 4, 5, 6 sig figs. That means my answer is going to need 2 sig figs, right? The smallest of those 2. So we'll multiply those together, 0.04 You don't have to put in the whole, like the 0 there in your calculator. Of course, it makes no difference in your calculator. It's just important for indicating how sure you are of the number. And that gives me 1,218. So this is a problem. I can't write down 1,218. That would be wrong. That's because that number has 4 significant figures. But then how do I indicate my number while only keeping 2 sig figs? This is where I have to use scientific notation. So I have to write it as 1.2 times 10 to the, my decimal would slide 1, 2, 3 places, 10 to the 3. So that's why we reviewed scientific notation at the start. It's really important that you're comfortable with it, because in order to report numbers correctly with significant figures, often we'll have to use it. Here's another one where our numbers are in scientific notation already, but again, for sig figs, we just need to worry about the first part. So this has 3 sig figs, and this one has 1, 2 sig figs. So my answer is going to have 2 significant figures, right? The smallest number of significant figures here. So 3.2 times 10 to the 4. If you haven't met it before, there's this handy EXP button on your calculator whenever you're doing scientific notation. The EXP, on some people's calculators, is actually written as a times 10 to the symbol. On mine it's EXP. That EXP means times 10 to the. So it comes up on my calculator as a capital E. It means times 10 to the 4. Just saves you a couple keystrokes. So it's times 4, again times 10 to the, so I'll do E2. That gives me this large number here. I can only write it out to 2 sig figs, right? Because this guy has just 2 sig figs here. So I'm going to need to round it to 1 point, that 2 will round off to a 3, times 10 to the, how far do I slide? 1, 2, 3, 4, 5, 6, 7 spots. There we go. My last one here. I've got 1, 2, 3, 4 sig figs, and here I have just 1 sig fig. So I can only write my answer to a single significant figure. Okay, so we'll multiply those out. 7.11 times 10 to the negative 3. Multiply that by 3 times 10 to the 5. And I get 2,133, but again, I cannot write that number down, right? Because that number has 4 significant figures, not allowed. I have to use scientific notation. The decimal slid 1, 2, 3 places. So I write it as just 2 times 10 to the 3. So only 1 sig fig there in my final answer. So most of the time you're going to be multiplying and dividing, but every once in a while you'll have to figure out how many significant figures your answer has when you're adding and subtracting. So for adding and subtracting, actually, you're not going to be looking at the number of significant figures in either of the numbers that you're adding together or subtracting from each other. You're just going to be looking at decimal places. So what you're going to ask yourself is, what is the smallest number of decimal places in any of the numbers that you're adding or subtracting together, and your answer has to have that number of decimal places. So for example, here's a number that has 1, 2, 3 decimals. This number has 1, 2, 3, 4 decimals. That means my answer needs 3 decimal places, right? It needs the smallest number of decimals. So that's going to be, when I add these two together, 207.778, and I have to stop there, just 1, 2, 3 decimals. Notice that this number actually has 5 significant figures, and I have an answer with more significant figures than that. That's totally okay, because for adding and subtracting, all I care about is the number of decimal places. It's not actually about which one has the smallest number of significant figures. It's a different rule. All right, this guy has actually 0 decimal places. This one has 1 decimal place. That means my answer needs 0 decimal places, so my answer will be 453, and we stop right there. This number here has 1, 2, 3 decimal places. This one has 1, 2, 3, 4 decimal places. So what I care about is decimal places. I need the smallest number, that's 3. My answer needs 3 decimal places, so it'll be 0.036, 1, 2, 3 decimal places. The only tricky thing with adding and subtracting, I find, is scientific notation. So for scientific notation, when you're multiplying and dividing, you're caring about the number of significant figures in the numbers that are multiplying or dividing. And that's just all wrapped up in those first three numbers, right? So you don't really have to worry about the scientific notation when multiplying and dividing, at least not for calculating significant figures. Of course, you need to worry about it for calculating your number, but not for figuring out how many significant figures to write down. That's not the case with adding and subtracting, because scientific notation does influence how many decimal places you have, right? This 10 to the negative 3 is going to change the number of decimal places that are actually here. There's not 2 decimal places here, there's actually quite a few more. So we have to rewrite our number as a regular number before we can add or subtract it in order to make sure we're getting the right number of decimal places to keep in our final answer. So 10 to the negative 3 means this decimal slid over 1, 2, 3 places, so rewriting it as a regular number, it would be 0.00123. Here the 10 to the negative 2 means a slide of 1, 2 spots, so 0.014. Now I can see what these numbers really are, right? I can look at how many decimal places they have. This one has 1, 2, 3, 4, 5 decimals actually. And this one has 1, 2, 3 decimals. Alright, my answer needs to have the smallest number of decimal places, so that's 3, and that will be 0.015, 1, 2, 3 decimal places, and I'm done.